So let's take a look at another example here. We have our another quadratic function. This is going to be a quadratic function, negative x squared plus 4. So we're going to plot some values and figure out what the change is, or the rate of change is going to be look like. And we're going to see if we can come up with a function for this rate of change. Okay, so let's start here at maybe negative 6. Okay, so negative 6, we're gonna negative 6 squared negative plus 4 is going to be negative 32. We'll go up by 2's. So negative 4 squared negative is negative 16 plus 4 is negative 12. Okay, and then negative 2, that's going to be 0. Well, 0 is 4. 2 is going to be 0. Negative 4, we get negative 12. Negative 6 is going to be negative 32. Okay, so when we plot this out, we're not going to be able to quite fit this in, but negative 0 is 4. Negative 2, 0. Okay, so we have those points there. Negative 4, negative 12, so it's just going to be just a little bit off here. Okay, so we're going to have this parabola. Looking something like that. Okay, and then we're going to find our rate of change. So our rate of change between the first 2 points is going to be, we go on plus 20 over plus 2. So our rate of change is plus 10. Okay, from here to here, our rate of change is going to be plus 12 over plus 2. Okay, so positive 6. This is going to be 0 to 4. 0 to 4 is going to be plus 4 over plus 2, so it's going to be equal to 2. And then we end up with minus 4 over plus 2, negative 2, minus 12 over plus 2 is going to be minus 6, and minus 20 over plus 2 is going to give us negative 10. Okay, so those are rates of change. That's our slopes, or the change in y over change in x. And we're going to find the average value of x between those 2 points. So we're going to say that's going to be negative 5. And just as we can see here, as we're kind of going up by equal increments, and we can see that there looks to be a linear pattern here. And this is what we kind of expected, the changes in y's. But now that we have our rate of change, which includes our change in x, we still have this linear pattern. Okay, so we're going to then work out some x coordinates here that we're going to use. The average between, so this is going to be positive 4 and positive 6. So it's going to be plus 3, plus 5. Okay, so what we're going to then do is see what we can do with these values here. So can we actually come up, based on some x positioning, is there a relationship between the x and the slope on that parabola? So what we're going to do then is take those same coordinates and we're going to plot them and see if we can come up with a function here. So it's going to be negative 5, negative 3, negative 1, 1, 3, and 5. Okay, and our slope values are 10, 6, 2, negative 2, negative 6, negative 10. And if we graph this, we can see that this is in fact a linear pattern. So negative 5 is 10. It's going to be up here somewhere, so it's going to be off my chart a little. In fact, I'm just going to skip that coordinate. So negative 3 and 6, right about there. Okay, -1, 2. Okay, 1, -2. 3, -6, right about here. And we can see that this is in fact a straight line pattern. Okay, we can see that it has a slope. In this case, the slope is going to be, the rise is going to be, looks like, let's see here, the rise is going to be -2. Okay, and the y-intercept is 0, so I can write this function as y. I'm going to call this y prime because this is the relationship of the x values to the slope, and we'll call that y prime. And the equation that we're going to get for that y prime value is -2x. Okay, so, and again, notice what do we notice about the degree of this function? The degree is 1, and we went from quadratic to a linear function again. Okay, so it looks like the rate of change of a quadratic function tends to be a linear function. Okay, and this is something that is true, and this is something that's very important and something that we want to look at, and we're going to use this property to do some analysis as well.